Hey guys, welcome back to Bioinformatics with R. Today we're going to be going over how to read and write tree files in a graphical way in R. So if you're interested in phylogenies or building evolutionary trees, then this video is for you. So without further ado, let's get started. Okay, so first thing, let's annotate. Let's load the required packages. So we're going to need 3 packages today. We're going to need ggplot2, ggtree. So this is all built on the ggplot kind of foundation, and then Treeio. So first we need to load our raw tree data. It's a Newick format, so we use ape read tree, and then we say what the name of our file is, itol.wnk. First I better run these packages. Okay, and we'll load our tree. So we got our itol tree. Now we will print out a very basic phylogenetic tree. So let's do ggtree and then itol. And I'll pull this up since it's behind my picture so you can see we have a tree from our tree data, where we have, you know, our most distant evolutionary ancestor or most distant common ancestor, and then all these tips of the tree would be different species. But we can do much better than that. So we can also change the format to make it a circular tree. So we do ggtree and we do itol, and then we say layout equals circular. So let's run this one. As you can see, this is just the same tree but in a different format, so we have it taking up 3 dimensions of space as opposed to essentially 2 dimensions. Well, it's as essentially one direction, right? And this is kind of fills the space a little bit neater, especially if you put tags and stuff on it, which we will get to in a second. You can also change the left, right, / up, down direction. So if we wanted, we can change it to something like this. We'll make a tree, but then we'll say chord flip and scale x reverse. And so when we do this, we get our original tree that we had. I think it's supposed to be plus, right? Yep. Let's run that. ggtree. Let's try it again. There we go. So now we've just flipped it. So if we went, I guess I can zoom. Oops, zoom in on the right one. So you can see it's the same tree as our first one, but we flipped it this way and this way. So in the 2 directions, we flipped them both. So depending on how you want your tree to look. By using geom tip lab, so tip label, we can add names to the end of tips. Alright, so to do this, we do ggtree. Scroll down so you can see what I'm typing here. ggtree for itol plus geom tip lab. Color, you can choose whatever. I'm going to choose Indian red. Why not? Which probably wouldn't be the best for publication purposes, but it'll stick out nice when we're looking at our example here. Alright, so if I run this, holy moly, If you zoom in, you might be able to see it better. It's kind of hard with this many tips to see what's going on. So I see streptomyces here. So these are all bacteria, right? Shigella. If you did, so let's try reducing our size down to 1, so maybe there'll be less overlap. Or let's do 1.5. That might work. There we go. Now it's just harder for my old eyes to read. So what you could do is you could save it as smaller text, but then export it as, this is just making our studio bigger. You could export it as like a TIFF file or a very high fidelity file and zoom in, and you'll be able to read them a lot better. But also this might be a learning lesson that if you have trees like this, you might want to reduce the size of the tree. So I haven't done this before, but let's try layout equals circular. Let's see what happens when we do this. Nothing. Okay, well, it was worth a shot. Okay, so moving on. Okay, so by adding a geom strip layer, we can annotate clades in the tree with a block of color. Say you want to show a specific clade or specific family within your tree, right? We can add the geom strip, so we can do ggtree itol layout equals unrooted and geom strip 1314 color equals red, bar size equals 1. So if we run this, you can see that we have the same chart here, but we've indicated 1314 is our node numbers. So nodes are these branches, right? We've indicated with our little bar what you want somebody to focus on, right? So you can then annotate and say, oh, this is the Shigella or something was up here. But we can get fancier than that even. So, so that's for an unrooted tree. You can highlight clades. Oh, what did I? In unrooted trees with blobs of color using geom highlight. So ggtrees itol layout layout equals unrooted plus geom highlight, node equals 11, type equals mcircle, so that's the type of blob we're going to make, fill equals steel blue. Oh, we're getting some sort of weather alert, I think, or something. Oops. Oh, those are probably from last night. That's funny. We had a tornado warning last night, and my phone is just now telling me that it's an issue. Good thing I was watching the news. All right, so let's make this new plot here. So let's run it. Cannot find function ggtrees because it's just ggtree. Okay, so it's going. Daylight method is so. Since we didn't specify layout, it's just saying that we're using the default daylight layout. while this is running, I'm going to start the annotation of the next one. So the above, actually I'm just gonna wait. So what you'll notice though is we have to give a node number for it to know where to draw, right? And if you're looking at this tree over here underneath my picture, so if we look at this tree, you say there's no node number, so how the heck am I supposed to know what number to pick for it to draw the right thing? So after this prints out, I'm going to show you how we can identify the node numbers. There we go. Oh, look at that tree. Beautiful. So we picked node 11, so that is probably right here. It's the center of your little circle, and so you've drawn this essentially the circle over the node that you're trying to point out in your tree. Oh man. Okay. So now we can use the MRCA, which is the most recent common ancestor function to find the node we want. So say we know that this is 2 species of Shigella and we want this node. So what we could do is we can use this MRCA, most recent common ancestor, which would be represented by this node, to identify what number it is. So the way that works is we use get MRCA, MRCA, there should be no parentheses there, ITOL, and our tip will give 2 different species that we're interested in. So we're going to do photorhabdus luminescence and Blockmania floridanus. Oh, get MRCA. I think this is supposed to be lowercase. Let's try that. Let's try this. Get MRCA. Is going on here? All right, so before we can do this get MRCA thing, there's a couple packages that I forgot to have them install on here. So we need to install BAM tools and then do library BAM tools. So run those real quick. I'll reload the library here. And so we do then get MRCA, which is lowercase, give it our tree that we're looking at, ITOL, and then our 2 species. We don't have to do tip or anything like that. And so when we run this, you can see we get our node number for the most common ancestor between those 2, which is the node number would be 206. So now if we want to highlight the section of the most recent common ancestor between the 2 above, we can do ggtree ITOL layout equals unrooted plus geom highlight node equals the one we identified, 206, type equals encircle, and then fill equals, do steel blue again because that looks nice. Okay, so if we run this, So it's creating our tree. And it should move the circle, so the tree should look about the same, but the circle should instead be on the most recent common ancestor between this P. luminescens and B. floridanus. So again, this is going to take a second. There we go. So you can see the circle got smaller, and we identified the most common recent ancestor up here between our two species. So we identified that clade. All right, so that's all I got for you for reading and writing trees. We'll continue to work with trees in the next video. This is just a brief introduction. I hope you enjoyed it and made some pretty trees of evolutionary history. With that, that's all I got, and I'll catch you in the next one.